Honors Geometry, Trooper Tide Tuesday, the 10th of November. We'll discuss the test. Hey, we did that, okay? Now students will be able to identify relationships between lines and angles, okay? Section 4.1. So, lines and angles, some quick review on it. A plane contains a finite number of lines. Is that true or false?
False.
That is false. Planes don't contain a finite number. They can contain an infinite number of lines because planes are infinitely long, okay, if you recall, okay? Okay. Hey, Mr. Work. You want to come back real quick? Okay. Hey guys. Another one. Okay. Hey, what do you call the intersection of two planes?
A line.
Perpendicular.
A crash.
Okay.
Oh my
Okay.
god.
Okay.
Okay, you guys want to hear mine for the day?
Oh, please.
What do you call a line of rabbits all hopping
Oh, yes.
backwards?
This is a good one.
A receding hairline.
Mm-hmm.
No.
There you go. Have a good
Nice.
day, guys.
Hey, nice haircut.
Thank you.
Okay. 2 points lying on the same plane are coplanar.
Yes.
That's true.
Yes.
If they're lying on the same plane, they're coplanar. That's true, okay? 3, true or false. If two distinct planes intersect, they intersect at exactly one line.
True.
That is true. If two planes intersect, they intersect at exactly one line. Okay? We can look at like maybe the wall and the floor, for example. They intersect at the line of where the crease is between the wall and the floor. Okay? That one spot. They don't intersect anywhere else. Okay? Number 4 is obviously not true or false since there's 2 blanks. Okay? A what? On number 4?
Yep.
Oh my goodness. Okay, I gave you guys
It's the same amount of space, it's just no space in it.
Oh. Okay. Wait. Oh.
No, it's not.
Bummer. Okay, I gave you guys the wrong copy. That's okay. We'll make this work, okay? Number 4, a line segment.
We should just scrap this whole, because
Oh, totally. Okay, line segment consists of 2 endpoints and all the points between them. Okay. Oh, totally. Okay. Now number 5, which I don't have written up here because I actually took it out, but we'll do it since you have it. Okay. A line, okay, contains an infinite number of points.
That's not what he said.
Yes, but in general, a line
Yeah,
is
just
not n.
line.
Just
Okay.
an infinite amount of points in it.
Okay, continuing on. Okay. 2 lines came. So if you have 2 lines, we can have some different options with them. Okay. So the first option is just they intersect and crash. Okay. They intersect at a single point. So 2 lines can just intersect at a single point. That can happen. Okay. And these aren't intersecting in any special way. They're just intersecting. Okay. What's up?
Can 2 lines intersect at a line?
Yeah, but it would still be at a point on another line. So like, let's say you were to draw another line through here. They're intersecting at a line, but it's a point on the other line.
That makes no sense. Okay.
So did you look up here on the picture as I said it? Okay, so there's this line here, and these 2 lines, the pink ones, okay, are intersecting at this other line. But it's really they're intersecting at this point on the line.
What if it's the 2 lines that are going in the same direction? And they're intersecting?
We'll talk about the other scenarios, okay? Okay. The second option, 2 lines can be, yeah, they can be parallel. You guys remember a symbol for parallel?
2 lines.
They're just those 2 little slashes, right? Okay, means parallel. You also can see them straight up and down sometimes. Okay, parallel lines, they never, ever touch, like train tracks or the stripes of the American flag, okay? We'll stop doing that.
Hey, you have your pen.
I know, I have it back up.
Whoa. I didn't even know.
The stripes of the American flag are parallel.
You should just make a wallpaper.
That would be awesome. Wallpaper the whole room with American flag.
Yeah, when they're touching.
Okay. Not if you take like the red ones or the white ones, okay. Number 3, okay, they can be the same line. You can have 2 lines graphed and they end up being the same line. You guys have this in Algebra 1 actually quite a bit, where they ended up being coinciding lines, and so they were infinitely many solutions when you're looking for the intersection of them in a system of equations.
Oh, yeah.
In Algebra 1, yep, that was a real thing.
I remember that.
Okay?
Algebra 1's not allowed.
Oh, okay. Okay. Okay, so
Pre-algebra.
on those parallines, a little add-on there. Okay, parallines are any two or more lines in the same plane that do not cross. And then we said our symbol is the slashes or straight up and down ones. Okay. What can't you read, buddy? All of it? Do you need to move seats today?
Yep.
Okay.
Did you forget your glasses?
No, Kaylee's not on them.
Oh, that probably doesn't help.
She's too.
Okay. Why don't you go into one of these two empty seats, buddy? Okay. Number 4. What do we think's happening with these two lines? They can be perpendicular. So they're intersecting like in number 1, but it's a more specific intersection. They're perpendicular. What's our symbol for perpendicular?
It's like a
It's not.
backward.
It's
It's an
exactly what
opposite
that is.
It's like an upside down T,
Yeah.
right?
Triangle.
Okay. Not quite.
Get an idea.
Okay. I'm not sure what kind of triangles you're looking at, buddy.
How does the triangle be upside down?
Okay. An upside down T.
Like triangle surface.
Okay. Number 5. What do we think number 5 is? Does anyone remember?
Parallel.
Right angle.
Oh, nice. They can be skew.
Yeah.
Okay. And if we recall, skew is very similar to parallel, right? Okay. That's why right below this we have conveniently this skew versus parallel thing. Okay. So both of them. Okay. The first one is the same. They both do not intersect. Nice.
Touch.
I mean, I guess.
Doesn't make any sense.
Hey, they don't intersect. Okay. You want to write down those calculators? Yeah. Oh, dope. Okay. So they both do not intersect. What? Don ought. Yes, okay. They both do not intersect, okay? Parallel lines are coplanar. They're in the same plane. So skew lines are non-coplanar. They're not in the same plane.
So why didn't we just put the symbols for the only one?
Watch.
Because I'm confused.
So we're just saying, hey, both of them don't intersect, but just heads up, this is the difference. So this is how they're similar, this is how they're different. Does that make any more sense, Gage, or no?
Oh yeah, look at that.
Yes. Okay, so identify the following using this diagram. So line parallel to line AB. So using this, can anyone tell me a line that is parallel to line AB? Okay, Jacob.
Line CD.
Okay, line CD. Is there another line that's parallel to line AB as well? Okay, line GH, right? Okay. Now, okay, is EF parallel to line AB?
No,
No, why not?
it's not in the same plane.
Not in the same plane. Okay, they don't intersect, but they're not in the same plane, okay? Well, like line FH doesn't intersect line AB either, but it's not parallel. It's skewed, just like line EF, okay? So, letter B, woof, okay? A plane parallel to plane EFH.
ACD.
Okay? Plane
ABC.
A... You said ACDGH? Okay. So any combination of those top 4 points, A, B, C, D, okay, can work. Did you say ACDC? Okay. Okay. So any three points of these top 4 is going to be parallel to this bottom plane. Okay. Question on that, going back to chapter 1. Okay. What's a line that's skewed to line AB?
FH. BH.
Okay, I heard a lot of different options. CE,
Any of
EF.
So I'm kind of confused. What is skew actually just like not parallel?
So skew means that they don't touch, but they're in different planes. So will line EF ever touch line AB?
No.
No, and they're in different planes.
Okay.
Now, will line FH ever touch line AB?
No.
No, and they're in different planes. So they don't even have to run the same direction. It's just the fact that they don't touch, and they're in different planes. Now, if they don't touch and they're in the same, then they're parallel. Someone want to give me letter D, a pair of parallel planes. For you guys, I think it's option 5. So we're going to skip option 4. So for you guys, it's option 5. Okay. Okay, Max.
A, B, G.
Okay, plane ABG and plane what?
CEF.
Okay, I would agree with that. That would work. Okay, there's 3 different options we really could choose. Plane ABG and plane CEF. So for us, it's kind of looking like this plane up in kind of like the front and the plane kind of in the back here. Okay, questions on that at all? Okay.
I guess I don't do it. Gone.
What was that?
Your other marker's been disavowed.
Ooh, that's fair. Okay.
Ours says
We're skipping 4. What?
ours says FE instead of CB. I mean,
Fourth lane.
EF.
Same thing.
It's the
FE
same.
instead of EF.
Yeah, FE and EF are the same. Yeah. So why are those not skew? So you can switch them around for the line. Yeah. So why are those not skew? Okay, Dominic.
Because we're on the same plane.
Okay. Yep, because they're on the same plane. Very good. So we could put they're coplanar. We could put they're on the same plane. Really, however you want to word that is totally fine. Okay. Questions on that? Alrighty. Continuing on. Let's talk about this thing called a transversal. So transversal is something that's new to us, okay? And we're going to use it a lot this chapter, okay? Like crap ton, okay? So transversal, what? It's kind of random, okay? It's one for each angle, okay? So a transversal is a line that intersects 2 or more coplanar lines at different points. So intersects 2 or more coplanar lines at different points, okay? So I'll put an example and a non-example. Does anyone know what a non-example means? It's an example that is not it, right? It's an example of what not to do, okay? So an example here, okay, will look something like this. So you have line A, you have line B, and then you have like a line C intersecting 2 different lines. So it's a line that intersects 2 different lines, A and B, at different points. Okay? And so in this example, okay, line C is our transversal. So the transversal is the one intersecting the 2 different lines. Okay? Gage.
So line M would be the transversal of K and N.
Yeah, so line M would be the transversal in our bottom example there that we'll get to in a moment. Yeah. So here's a non-example for you. Oh, thank you, Jebby. Okay. So here's a non-example. What? Yeah, I would encourage you guys to write down the non-example as well. Yeah, great question. Okay. So a non-example would be like line E, line D, and line F, because these are intersecting at the same point. So you could say like, well, yeah, line E as an elephant intersects line D, doggo, and line F, fantastic, doggo, intersects 2 different lines, but it's at the same point. So rather than intersecting at 2 different points, it intersects 2 lines at the same point, okay? So that would not be an example of transversal. Does that make sense of the difference between those two? So we're still having a line intersecting 2 others, but the difference between them is on the left, it's at different points. On the right, it's at the same point. So the left is a transversal, the right is not, though. Questions on that at all? Okay, so we're going to talk about this idea of interior and exterior angles. Interior means what?
On the inside.
Inside, right? Exterior means what? On the outside, okay? So interior angles are going to be, we're going to define that as between 2 lines that are cut or intersected, okay, cut by a transversal. So here, we said that line M was the transversal, so I'll go ahead and write that down. So line M is our transversal here. And if we look at lines K and N, those are the two lines being cut by the transversal or intersected by the transversal. Now, we see some angles inside or between these two lines, and we see some angles outside these two lines. So the interior angles are going to be the ones between the two lines. So can somebody tell me one angle that's between those two lines? Saren. Okay, angle 2. Okay, can somebody tell me another angle? Gage.
4.
Okay, angle 4. Can somebody tell me another angle? Okay, Aiden. Okay, can somebody tell me the last angle? Okay, Jacob.
Angle 5.
And angle 5. So those are all examples of interior angles on this diagram. Okay, so exterior angles we're going to define as outside two lines that are cut by a transversal. So we're still comparing it to those two lines that are cut by the transversal, but instead of being inside them, they're outside them. So can somebody help me out with one of these angles? Dominic.
1.
Okay, angle 1. Help me out with another angle.
Angle 2.
Okay. Not angle 2.
No, I meant to say 3.
Okay, angle 3. Okay, Liam.
7.
Okay, angle 7. And Sierra? Angle 8. Very good. Okay. So now, could an angle be both interior and exterior? No. Okay. You can't be both inside and outside on these. Okay.
I'll be back.
Okay, you can't be both inside and outside of these. Okay, Aiden, you question? You have a question?
Question.
Okay.
What if it's angle 1, 2?
You wouldn't have an angle 1, 2. You would say angle 1, angle 2. Like they're separate. Does that make sense? So you could end up having are you saying what if we were talking about this entire angle as one angle? Okay, so if we were talking about that entire angle as one angle, we'd say that is neither interior nor exterior. Does that make sense?
Yes.
So we wouldn't say it's both, we say it's actually neither. Because it's not between them, it's not outside, it's just a different angle. Okay, it's just built different. Okay? Question on this that haven't been asked already. Okay? So if we move on a couple pages ahead, okay, I know it's a couple pages ahead with the way the notes are structured, okay, to the table.
We should just get those in.
Okay?
What's on the table?
Okay? Yep. Okay?
Down the table.
Okay? So it should be the only table. It should be going landscape compared to portrait orientation on your paper, if you know what that means, sideways instead of up and down. Okay. So this is the top row of the table. Now notice I kind of had to split it up just so I'd have room to actually write in it up here, because otherwise I wouldn't have. So here's the first 3 boxes, and then here's the last 2 boxes of the first row. Okay, that makes sense? So we're gonna have these different angle types. Okay, we're gonna have classifications of angles. Okay. And so that's one of the things we're doing is relationships between lines and angles. These are different angle relationships, okay? So we're saying we'll have these 5 that we're talking about. We talked before about vertical and linear pair, okay, and adjacent and all those, okay? We're adding in some more ones, okay? We're adding in 5 more today. So the first one is corresponding angles, okay? So corresponding angles there. So here's just a normal picture of 2 parallel lines, A and B, being cut by a transversal, okay? We're going to start with the description, okay? We're going to start with the description. So there are going to be 3 bullet points and then 1 parenthesis I'm going to put in here. Just so you know what I'm going to put, there's going to be 3 bullet points and 1 parenthesis. That way you're not blindsided by how much information it is, okay? So there is going to be 1 interior, which you can put INT for interior, and that's my and symbol. 1 exterior, or I'm going to abbreviate it EXT. Okay, this is going to be 1 interior and 1 exterior. And whenever we talk about these, they're always going to be pairs of angles, so sets of 2. Okay, that's kind of. That's why I tried doing that one that way, so it wouldn't look as much like an L or an I. The second bullet point is they're going to be on the same side of the transversal.
Why'd you write the whole thing out?
Yeah, I just did trans.
Okay. For transversal, we're going to write the whole word out because we shortened it for transitive property earlier. So we don't know which one we'd be talking about. Okay? Saren. TRANSV. Oh, you're suggesting a way to shorten it. Well, we'll just write it out as transversal. We won't have to write transversal often. Okay? We're going to have to write it a couple different times a day. But like other than like in this like table, we aren't going to have to write it much. Okay? So we're not concerned with shortening it down. Okay? The third one, they're going to be the same position at the intersection. They're going to be in the same position at the intersection. So kind of a helpful way to help remember this, okay? Helpful way to remember this is this parenthesis I'll put at the bottom, is that they're on the same side of the transversal, and they're in the same spot. So they're on the same side of the transversal, and they're on the same spot at the intersection. Okay, and that's all we'll put in the description one. Okay. So I mean, it depends on where the transversal is. So they're the same side of the transversal. Okay, so we took same side, same position, same spot. So, for example, angles 1 and angle 5 would be a pair of corresponding angles here. So angle 1 and angle 5 would be a pair of corresponding angles, okay? And here's why. One is interior and one is exterior. Angle 5 is inside of these two parallel lines, or these two lines cut by the transversal, Angle 1 is exterior, outside the two lines that are cut by the transversal. So it hits the first description. They are both on the same side of the transversal. The transversal is running up and down at an angle. They're both on the left. And they're both in the same position at the intersection. Angle 1 at this intersection up here is the top left angle. Angle 5 is also the top left angle just of this bottom intersection. Yeah, so 2 and 6 would be corresponding angles as well. Okay, so 2 and 6 would be corresponding angles as well. Okay, because they're both in the top right of those. Okay, so I always end up kind of thinking them as same side, same spot. Okay, top right of the intersection. Okay, Dominic.
What about 4 and 8? Would that be one?
Okay, 4 and 8 would be another one.
About 3 and 7.
Okay, and then 3 and 7. Aiden, I think I heard you say that earlier as well. Okay. Does this one make a little more sense than maybe it did when we were just writing the description?
Yeah. I don't know.
Okay, Aiden?
Wait, go ahead. Upside down 7 and then a 7 normally.
Does kind of look like that, okay?
It looks like
The way that I draw mine, it's not looking it upside down 7, but it would make like it's not that.
Okay. Well, sure, I'll react to that, okay? Any question on this? Okay, we're going to fill in the facts later, okay? We're going to fill in the facts later. We're going to go back to that part of the table, okay? And that's going to be the way for all of these. So we're going to move on to the next one here. Alternate exterior angles, okay? So we're going to start with the description again. This time, we have 2 bullet points, no parentheses. So 2 bullet points here, okay? First bullet point is they are both interior. INT if you want to shorten it. Both interior. Hi, Kenny.
Hi, Kenny.
Hi, Kenny.
The second bullet point is they are on opposite, or I can shorten it down to OPP, opposite sides of the transversal. That's all you have to write in the box. So they're both interior, hence the name interior, okay? And they're on opposite sides of the transversal. Where do we think we see that in the name? Where do we see that? Alternate. Alternate means they go back and forth, right? That's what alternating means just in real life, okay? Is that something goes back and forth between two things, okay? They switch, okay? So this is meaning they switch sides of the transversal. Interior, they're both inside those 2 angles that are cut by the transversal. Does somebody have one that they thought that might be alternate interior angles? Okay, Kelly. Angle 4 and angle 5. Very good. Angle 4 and angle 5 are on different sides of the transversal. Angle 4 is on the right, angle 5 is on the left, and they're both inside these two lines. Okay, Dominic.
Angle 3 and angle 6.
Angle 3 and angle 6. Angle 3 is on the left, angle 6 is on the right of the transversal, so they alternate. And they're both interior, they're both inside. Do we see any others that are both alternating and interior?
5 and 4.
1 and 4.
Okay, 1 and 4. Okay, so are those both interior though? Right, so they do alternate, but they're both interior. So they don't fit this one, okay? Those would actually be vertical angles back from chapter 1.
6 and 3.
Okay? 6 and 3. Oh, we already covered that, okay? Okay, so it doesn't matter whether you call it 5 and 4 or 4 and 5 or 3 and 6 and 6 and 3, okay? It's the same pair either way. Okay? Questions on that? Okay, moving on. Alternate exterior. I bet you guys can't figure this one out, okay? So alternate exterior. These are both exterior. What? No way, okay? And these are also on opposite sides
That was difficult.
of the transversal. I thought so.
Yeah.
I thought after doing alternate interior, your minds were just going to explode for this one.
Yeah.
Okay? So they still alternate, but instead of being interior, they're exterior. What were we saying, Kelly? Oh, I'm sorry.
Okay.
Yeah, it is your fault for having a cold.
Yeah.
Okay.
She has
Anyway.
Okay. All right. I mean,
Fair.
it sucks.
It sucks.
Okay. Raise your hand if you want to tell me a pair. Okay. I was going to say show. Just so we're clear. Just so we're clear, that word was going to be show. Okay? Just so we're clear, that I changed it to tell. Okay? I don't want anyone to think anything else. It was going to be the word show. Okay? So raise your hand if you want to tell me or show me a pair of alternate exterior angles. Levi. Okay? Angles 1 and angle 8 would be a pair of alternate exterior angles. They alternate the sides of the transversal, left and right, and they're exterior. Sierra. 2 and 7 would be our other pair. Man, that would have been wrong though.
What?
Okay.
Would have been worth it.
Yeah, no, 7 and 2, 2 and 7, same thing. Okay. Questions on that? Okay, watch YouTube make my video restricted now because I said something that could have ended like that, even though it was gonna say show, just so we're clear. Okay.
He just got demonetized.
Yeah. My plan is ruined. This is the real reason I make videos, not for you guys. Okay.
For the fans.
Yes, for the fans, okay? Consecutive, or we're also going to call it same side interior angles. What does consecutive mean? One after another, right?
Monday, Tuesday, Wednesday.
Yeah, they're sequential. That's one after another, okay? They go in a sequence or an order, okay? Or we're also going to call these same side interior angles. So our description for this, okay? We're going to have 2 bullet points again. These are both interior, hence the name interior.
Whoa.
I know, mind blown. Okay? And these are on the same side of the transversal. I bet you guys never could have guessed that from the name, right?
I could have not.
That would have been difficult.
It's pretty big brain.
Notes for the next one.
What was that?
I'm just filling the notes for the next one too, because I'm feeling.
If you want to try, I suppose, okay? So does anyone want to show me a pair of same side or consecutive interior angles? Jacob.
Angle 4 and angle 6.
Angle 4 and angle 6. They're on the same side of the transversal on the right, okay? And they're both interior, those two lines that are cut by the transversals. Does anyone want to give me the other pair here? Okay, Saren.
3 and 5.
3 and 5, okay? Angle 3 and angle 5. Both on the left side of the transversal, and they're both interior. Now, they can be called both consecutive and same side. Typically, I'm going to call them same side more often than not. But I just want you to know that they could be called by either description, okay? Does it make sense why they're consecutive?
Yes.
Because if you're looking, you're just going, 3 to 5, they're on the same side of the transversal, or they're consecutive just in a row. You're not crossing anything. Okay. Continuing on, same side exterior. Okay. So our description for this, does anyone want to guess what my first description is? They're both exterior, and they're on the same side of the transversal. Okay. So who wants to give me a pair of same side exterior angles? Okay, Aiden.
7 and 1.
Okay, angle 7 and angle 1. They're both on the left side of the transversal, and they're both exterior of those two lines. Now, we could have said angle 1, angle 7 wouldn't have mattered. Bill, go ahead.
8 and 2.
8 and 2. Actually, it's angle 2 and angle 8, okay? Angle 8 and angle 2 would work just fine. Those would be the other pair of same side exterior angles, okay? Question on any of these? Okay? Yep, we're not quite doing the facts yet, okay?
Never doing the back. I'm never doing it.
Okay? Show me the Carfax, okay? Let's go back to where we left off.
What? I thought those were done.
Backwards.
Okay?
Back to this
How
one.
messed
I
up
already
are these
recommend.
notes?
How come we get colored?
How what?
How messed up are these notes?
Decently.
That point B.
Okay? Yes. Okay? All right. So name a pair of angles that fits each description. So we have these two lines, line L and M, cut by the transversal T.
Where is this?
Okay? Yes, it was the page we were previously filling out, and it's at the bottom of that page. So where we first were writing about interior and exterior angles and transversals. Okay, so it was the second page of our notes. Okay, if you count page 1 as the front, page 2 as the back, very bottom. Okay, I want you guys to try filling these 4 questions in the best you can. So, and letter A. Anyone have an example of alternate exterior angles? Okay, Aiden.
Angle 1 and upside down 7 and 7.
Okay, angle 1 and angle 7. Okay, that could work. Is that the only pair you could use?
Yes.
No, you could also use 2 and 8.
No 7.
Okay. What about letter B? Consecutive or same side interior angles? Bill.
5 and 4.
Okay. Angle 5 and angle 4. Is that the only pair you could use?
Yes.
No, because you also use 3 and 6. Okay. Letter C. Alternate interior angles. Who wants to give me a pair for that? Okay, Levi.
4 and 6.
Okay, angles 4 and angle 6. You could also use angles 5 and 3 if you really wanted. Okay. And letter D. Corresponding angles. Aiden.
Angle 3 and upside down 7 and 7.
Okay, angle 3 and angle 7. You know, I feel like you just picked those on purpose. Now, those are also 4 different pairs you can use for that, okay? Now, I want to add on real quick the vertical angles, okay? Vertical angles, I don't want us to lose those. Vertical angles. Can anyone tell me a pair of vertical angles real quick? Okay, Gage.
1 and 3.
Okay, angle 1 and angle 3, very good. Okay, can anyone tell me a linear pair real quick? Okay, angles 5 and angle 6, awesome.
That's too much math.
Okay, questions on that at all?
Linear pairs just 2.
Yeah, and they make a straight line, so they also have to be adjacent.
What about the question for you?
Who has a question for me?
No.
Oh, Dominic, you do?
Yeah, what are we using in line?
Great question. So, this specific map, you may or may not use it, depending
What?
on what you end up doing. Okay, so like certain careers, we'll never use this. Certain careers, we'll totally use this. Okay, it totally depends. Okay, so let's say you're going to do some sort of construction, design, that kind of stuff. Which there are roles like that in the army, depending on what you're doing in the army. Okay, infantryman, maybe not. Okay, but different construction or design. You might end up using properties of different angle relationships to actually make sure things are laid or designed correctly, so that way they're foundationally sound. That could be a place you could use it, for example. I can come up with others later, but that's one for now. Anyway, classic question. I'm used to them. Okay. So let's flip the page over. Example 3. Okay. Transversal here is line what? R. Like a pirate. Okay. Hey, do you guys know R is the most menacing of sounds? Okay. Do you guys know that there's this National Talk Like a Pirate Day? Have you guys ever heard of it?
No.
Okay, it's in the fall. It probably actually already happened this year. Anyway, so every year, Krispy Kreme does this promotion for it, and National Talk Like a Pirate Day. To where if you go into any Krispy Kreme and you say R, okay, they will give you a free glazed donut. Okay, and if you go in and you dress up as a pirate, okay, and you have to have like a minimum, I think it is of like 3 items of clothing that are like pirate-like. Okay, so like maybe like a hat, an eye patch, like sword. Okay, probably not a real sword. They probably won't let you in. Okay, but maybe like a fake sword. Okay, and they'll give you a dozen free glazed donuts. Okay? So back when I was in college, okay.
That's worth it.
Like actually.
So yeah, actually, it's a real thing. Okay, so back when I was in college, there would be like groups of people. So like you'd be like, 3-4 people pile on a car, all dressed as pirates, and they'd hit up like 3 different Krispy Kremes, and so they'd come back with like 9 dozens of donuts. Okay, because each person would get a dozen at each Krispy Kreme, and like I actually never did it, but here's the thing. They would come back with 9 dozen donuts. And so they're like giving away donuts like crazy. And so like I always ended up getting a bunch of donuts anyway. And so it was like the best thing ever. Okay? What?
108 donuts.
Good math. Okay?
What's that now?
Yes.
They should have charged me for it.
Right? Oh, like sell the donuts? Ooh, okay, that
When's
might be big
that would
brain.
be genius, but when's the day?
Okay, I don't know. Okay? You can look it up real quick, okay? I'll give you permission to get out your phone and look it up, okay?
You know how
Liam.
there's like those dumb like national days or like National Kick a Ginger or whatever? Today's November 10th is National Slap Your Sibling Across the Face Day.
No way.
Alright.
I think it's younger sibling
Wait.
too.
Oh, do you want me to go find Ava?
September
Yeah.
19th.
Wait, no.
It
Find
was
Ethan.
September 19th.
Okay, September 19th. Ah,
This
okay.
year.
Okay.
Oh man, we missed it.
So, just heads up. So next year, non-pandemic, hopefully, that would be the time that go
Wait,
dressed
what
like a
day?
pirate.
September 19th.
And
I've only
anyway.
once and it changed my life.
So they're pretty good, okay?
Where
They're not the best, but like when they're like fresh and warm, like they're pretty darn good.
Where is it?
There's that.
There's like a few different Krispy Kremes in Omaha. I'm having trouble remembering where any are at now.
The
But
one's
like,
like sort of by Dave and Buster's, but not really. In the same area.
okay. Yeah.
It's like around that area.
Okay. B. Corresponding angles that are on corresponding angles are on the blank of the transversal.
Like blank.
I'm not writing that.
Same side. Very good, Kelly. Same side of the transversal.
You wrote it wrong. It's supposed to be B, L, A, and K. That's why it's spelled blank.
Oh yes. You're right. Blank. Okay. Name 4 pairs of corresponding angles. So someone raise your hand to give me a pair of corresponding angles. Okay.
Yes.
So 4 pairs of corresponding angles. Raise your hand for 1 pair of corresponding angles. Okay, Saren.
1 and 3.
Okay, angles 1 and angle 3. Awesome. Raise your hand for another pair. Okay, Liam.
2 and 4.
Okay, angles 2 and angle 4. Raise your hand for another pair. Kelly.
Angle 8 and angle 6.
Okay, angle 8 and angle 6. Awesome. Raise your hand for the final pair, Billy Bob.
7-5.
Okay, angle 7 and angle 5. Okay. Okay. Question on those at all?
Give me a second. I gotta write this down.
Oh, okay.
Right, this down.
I said either you're not writing.
Yeah.
I didn't even write angle.
Yeah, I did that. Angles like
No, I didn't even do that either. Too lazy.
Look how fast I did that.
it wronged me.
It did.
Look how fast I did
It didn't right you or left you. It wronged you, okay? Corresponding angles postulate. So we have another postulate, okay? So about corresponding angles. So when two parallel lines are cut by a transversal, the resulting corresponding angles are congruent. So if the 2 lines cut by the transversal are parallel, any corresponding angles we have would be congruent. So on this previous picture, are lines M and N parallel?
Yeah.
No, like they're clearly not, okay? And they're not marked. If they were, then corresponding angles would be congruent. That 7 and 5 would be congruent, angles 2 and 4 would be congruent, so on and so forth. But they're not, so that's not the case, okay? Let's use this as we skip over this part for now. And we look down at example 1. Okay? Hey guys, plot twist. You're not going to have homework today.
Oh, no. What?
Okay? Okay?
Let's go.
Just do it. You know, I'm just not gonna say anything.
Wait, which page is it on?
Okay?
Right there.
Not fun. We don't have homework.
Oh.
Wow.
Here are the left 2. Here are the left 2 of the 3. Okay? I had to split them up so that way it'd fit on here with the watermark. Okay? So given that these two lines A and B are parallel, find the missing value. So in this case, we're trying to find variable A. So what kind of angles, we need to go back before we go back and do that. Let's see here.
What's it called, the water?
Oh, so here's the worst thing, okay, with these masks, okay? I can't lick my fingers to grip anything. You guys know what I'm talking about?
No.
Okay? Like you're going to the grocery store or something like that?
I never grip anything.
Well, it's good.
I've
It's
never done
protecting
that
you
before
from
in my
rodents.
life. Like, what it always means, I can't blow the eraser thingies off my desk. And then it annoys the crap out of me.
Do this.
I always erase a lot, so I try and like blow the eraser. But like, yeah, no, that's not Oh, that's
That is big sad. All right. Let's go back here, okay, to the table. Okay, we're going back to the table. I'm changing up where we're at, excuse me. Okay. So this facts, go ahead at the top of the facts table, put in when two lines are parallel. Okay, go and put in when two lines are parallel. Okay, when two lines are parallel. So if lines A and B in this example, okay, in the picture are parallel, corresponding angles are, we just learned?
Congruent.
They're congruent, my goodness.
I like that. Do it again.
Okay, when two lines are parallel, corresponding angles are congruent. Okay, that was like a very, really good squiggly. It was like intense.
That's very
But
good.
the line was
No, on yours.
oh yeah.
I was like, well, you're giving a lot of attention to it, okay? Let's say on this picture,
I can't draw.
someone give me a measure for angle 1.
35.
Okay, give me a realistic measure for angle 1 given the look of the picture.
120.
120, cool. Okay, so let's say angle 1's 120 degrees, okay? Okay? So what else do we know if the lines A and B are parallel, which they are marked to be?
5
Okay, angle 5 is also 120 degrees because they're congruent, right? Okay? Okay?
Wait, that doesn't.
Angle 2 would be what?
60.
Okay, how do we know that?
Because they're supplementary.
They're supplementary because they make a linear pair. So is there another angle we can know now?
3 is 60.
Raise your hand. Okay? Max.
3 is 60 as well.
Angle 3 is 60 as well. How do we know that?
Vertical angle.
Okay? They're vertical angles with angle 2. How else could we know it?
Math.
Is it also a linear pair with...
3 and 1 are
That's a
supplementary.
linear pair.
Because 3 and 1 are linear pair?
All right.
Okay? Is there... Raise your hand for another angle we could know. Okay? Gauge.
4.
Okay, angle 4. How could we know angle 4?
Because it's vertical with 1.
Okay?
And it's the linear pair.
Linear pair with 2 and 3. So what's the measure?
120.
120 degrees. Okay? Raise your hand if there's another angle we can know. Bill.
7. It's the exact same as 2.
As 2?
Yeah,
Yep.
but it's realistically.
I think you mean as 3 maybe?
Maybe, I don't know.
Okay, well what are angles 3 and 7?
Parallel, something, alternate.
Okay, somebody want to help? Bill, what are 3 and 7? Okay, Israel.
Consecutive exterior.
Not quite. So 3's interior, but 7's exterior. Saren.
Corresponding angles.
Corresponding angles. So they're congruent since these two lines are parallel, okay?
Also, this is the same line. It's like, yeah.
Okay. Now, do we also know 7 in another way?
Linear pair.
Linear pair with angle 5. Okay, what's another angle we could know? Raise your hand for another angle we can know. Okay, Aiden.
6.
Angle 6.
And 27.
Okay. 6 is what?
60.
Okay, 60 because it's vertical angles with 7. Is it also corresponding with 2? So they're the same, okay? Is it also a linear pair with 5?
Sure.
Okay. What about angle 8? Raise your hand if you can tell me the measure for that, okay? Max.
120.
Okay, how could we know that?
Because it's linear pair with 7 and then vertical angles with 5.
Okay, linear pair of 7, linear pair of 6, vertical angles with 5, and corresponding with 4. Does that make sense how we got those measures to anyone?
Yes.
Okay, so notice we started with one measure and we were able to find all the other 7, weren't we?
Yay.
Okay, so now can we notice something here? Okay, you said corresponding angles are congruent, and that does end up being the case. Okay. Could we also know? Okay.
A copy of itself.
Okay. Could we also know? Do we also see something about maybe alternate interior angles, like angles 3 and angle 6? What do we notice about those?
Congruent.
Those are congruent. What about angles 5 and angle 4? Those are congruent. Okay. That's another thing we can write on here then. Alternate interior angles. When the two lines are parallel, they're congruent. Alternate interior angles, when the two lines are parallel, they're congruent. What about these alternate exterior angles? Angles 1 and angle 8, alternating sides of the transversal, both exterior. What are they?
Congruent.
What about angles 7 and 2? Congruent. So, alternate exterior angles are congruent when those two lines are parallel as well. Now, these facts are only true when those two lines are parallel. Just so we're clear. Okay. Well, what about same side interior? Angles 3 and angle 5.
The linear.
They're not congruent.
They're not congruent. They're not linear. They add a 180, which is supplementary. What about angles 4 and 6? They're supplementary as well. So same side interior angles, when two lines are parallel, they are supplementary.
Right.
What about our same side exterior, angle 1 and angle 7? Supplementary. What about our 2 and 8? Supplementary. So when the two lines are parallel, those are supplementary as well. Isn't that kind of neat? We were able to fill all these in with only one angle earlier. That's kind of cool. Okay. We are.
Did I miss
Time to
something?
clean up.
We're going to stop there today.
Yeah.
Okay.